In this question, we're going to determine which of these rows is correct by determining which particles actually experience these fundamental forces. So it tells you gravity already acts on all four of these particles, and that's because all four of these particles already have mass, and all particles with mass have gravity acting on them. Now, electromagnetic force only acts on charged particles, so let's make a quick note of that. Charged particles. The weak nuclear force is a little bit different. It acts on hadrons and leptons. So hadrons can be further split up into baryons and mesons. Some examples of baryons you need to know are protons and neutrons. Some examples of mesons you need to know are the pi meson and the k meson. Now leptons, some examples you need to know of them are electrons, neutrinos, and also the muon. Okay, let's now move on to this question. So a positive muon is a charged particle, so it does experience the electromagnetic force. Because it is a lepton, it does experience the weak nuclear force, and it doesn't experience the strong nuclear force because it's not a hadron. So this is the correct answer. But let's go through all the others just to make sure you guys understand this. So an antiproton, because a proton has a charge of +1, an antiproton, an antiparticle, has that opposite charge, so it'll definitely have a charge, and it also has that same rest energy. That's the definition of an antiparticle. Does it experience the weak nuclear force? Yes, it does, because it's an example of a hadron, and hadrons experience the weak nuclear force and the strong nuclear force. So, by the way, I'm just going to label here hadron. Okay, that's completely fine. Because this middle box was missing, that's why this row is incorrect. Moving on to this next particle, this is a pi naught meson, meaning it's uncharged. Because it's uncharged, it won't have the electromagnetic force acting on it, so this is incorrect. Moving on to the neutrino now, again this is uncharged, so it won't have electromagnetic force, that's correct. It will have the weak nuclear force acting on it because it is an example of a lepton, but it won't have the strong nuclear force acting on it because it's not a hadron, so this is incorrect as well. Hopefully that makes sense to you guys. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.